Hello, welcome to the Matlab video series, Chapter 4, Using Script Files and Managing Data. What is a script file? A script file is a list of Matlab commands called a program that is saved in a file. When a script file is executed, Matlab executes the commands. Let's look at who, which is a command which helps you to display a list of the variables currently in the workspace. Then we have whos, which displays a list of variables currently in the workspace and the information about their size, bytes, and class. We have a few examples here. So let's work on the Matlab window to understand these commands better. So I'm defining A as a string, and two new variables here, b equals 2 and c equals 6, and let's use b and c for some calculations. So b raised to c, b plus c, and b over c. And another variable called e, which is going to use d and b together. When we run this, let's save this as C4. You get the following results. Now, in the command window, if we just say who, type who, we will get the list of variables used, which are A, B, C, D, and E. If I type whos, W-H-O-S, it displays the variables used along with the size. So, for example, A was a string and it's got 9 letters in it. So it's got 1 row and 9 columns. And bytes, it occupies 18. Class attributes, it falls under the character category, whereas B, C, D, and E are numbers, so they fall under double, and their sizes are also listed. B is just a single number, C as well, so 1 by 1, and D and E are both vectors with 1 row and 3 columns. How do we put an input to a script file? The variable is defined and assigned a value in the script file, or else the variable is defined and assigned a value in the command window. And the third case is the variable is defined in the script file, but a specific value is entered in the command window when the script file is executed. The form of the command is you give a variable name equals input, and then whatever message you want to write, you put it as a string within single quotes. Write a Matlab code that asks the user to input the game scores for 3 games, Game 1, Game 2, and Game 3 separately, and then finds the average score. So let's input these values using the input command. So Game 1 equals input, enter the score for Game 1. Similarly, we can repeat the commands twice because we want to write the scores for Game 2 and Game 3. So we have Game 2 and Game 3. Similarly here as well, let's change that to Game 2 and Game 3. Now let's run this and see. We see that we get the text message displayed twice. So in order to avoid this from occurring, whenever we use the input command or the output commands like display, fprintf, etc., you should always switch echo off. Now we have to just exit this loop. So just enter some random values. Now run once again, and we see that we just get the desired message. Now we can type in any score that we want, and it's done. Now let's find the average. So the average score will be the sum of game 1, so game 1 plus game 2 and then game 3 divided by 3. So let's enter the values. We get the average score as 42. Now let's discuss the output commands, which are the display commands, so disp, and then the fprintf. First of all, the display command. It is used to display the elements of a variable without displaying the name of the variable. So display disp, and then you just type in name of the variable. Or to display a text, you type in display and then the text as a string. So we have an example here. ASD is a matrix with some values in it. So if you want to display that matrix, you just say display and then the name of that matrix, which is ASD. But if you want to display a text message, you have to write that within single quotes. That means define it as a string. So display, the problem has no solution. It is defined as a string within single quotes, and you get the desired message. So we can apply that to this example as well. If you want, you can display a text message, display average score, and then below it you want to display the value. So display average underscore score. So that is the name of the variable where you have stored this value. So we can suppress whatever else is there earlier. And we can run this file, plug in some values for the game scores, and we get the desired result, average score, and then printed below it the value of the average score. Now let's discuss about the next output command, which is fprintf. Fprintf command is used to display output on the screen or to save it to a file. The output can be formatted as well. So this is the advantage of the fprintf command. Text and numerical values of variables can be intermixed and displayed in the same line. And format of the numbers can be controlled as well. Let's look at this example here, using fprintf command to display a text. So we say fprintf, the problem has no solution, period, check the input data. So it displays the message. But if you want to go to a new line, you have to use a new line character, which is \n. To start a new line in the middle of the string, insert a new line character before the character that will start the new line. For example, fprintf, the problem has no solution, period, \n, which is the new line character, please check the input, and then close the quote. So you get the output displayed in 2 new lines. Here is how to use the fprintf command to display a mix of text and numerical data. fprintf, start the quote, text is a string, then use the %sign to indicate that is the spot where the number is inserted. Then a negative sign, so this can be negative, positive, or 0. We'll discuss that later. So that is called the flag. Then the next one is the 5, which is the field width, so that will depend on your output. Then we have 0.2, which is to say if you want to correct the value to 2 decimal places. If you want it to be 3 decimal places, you have to use 3. And f is another formatting element to say that it belongs to floating point numbers. Then you can type in some additional text, close the quote, put a comma, and then where does this variable lie? So you have to put the name of the variable. Let's discuss formatting in a little more detail here. So as I said in the previous slide, this negative, okay, is called the flag, so that is optional. Then 5 is the field width and precision, that is also optional. And F, that is the conversion character, that is a required field. So the last element in the formatting elements which is required is the conversion character, which specifies the notation in which the number is displayed. So here we have the flag. It can be a negative, it can be positive or 0. If you put negative before the field with 5, it left justifies the number within the field. If you put positive, it prints a sign character, that is, if the number is positive or negative, in front of the number. And 0 adds 0 if the number is shorter than a field. Now let's discuss something more about formatting. We have different notations. If you use the letter E, the small letter E, it means exponential notation using lowercase e. So the output will be displayed in this format. If you use the capital letter E, then exponential notation using uppercase E. So output will be displayed in this format with a capital E in the scientific notation. F, as we discussed earlier, is for fixed point notation. So it will display the decimal numbers. If you use letter G, it will choose the shorter of E or F notations. Capital G, the shorter of capital E or capital F notations, and I if it's for displaying an integer. fprintf is vectorized. This means that when a variable that is a vector or a matrix is included in the command repeats itself until all the elements are displayed. We can understand this better using this example. Write a program to display the square root of numbers from 1 to 5 as a repetitive text. So we can write x as from 1 to 5 and y is square root of x. Let's have a look at the output. We need to exit this once. So x equal to 1 to 5 is not displayed because echo is off, but the value is already there. And y has all the values of the different square roots. So y is basically decimal numbers or floating point numbers, and they're all corrected to 4 decimal places here. By default, they are in format short. Now, if I want to display this, I will use this format. Display x as a row and below it the y values. So let's look at this table. Exit this once. We can comment this in fact so that it does not interfere with our program. Okay, so we have the values of x and the values of y displayed one below the other. Now we need to type a repetitive text. So we'll use fprintf if the number is, here we'll display the number that we want to type. If the number is x, so the x values are all integers and maximum it occupies just one space. Okay, so we'll just use I. If there are 2 spaces, you will say 2i. So if the number is %i, then its square root is, at this position we are going to display the square root of that number. And when we look at the output, it occupies a maximum field width of 1, 2, 3, 4, 5, 6, including the decimal point. It occupies totally 6 spaces, so %6, and we would like to correct it to 3 decimal places, so 0.3, and then the conversion character, which is mandatory. So it belongs to floating point numbers or fixed point notation. So F. And then we close it with the \n, which means it'll go to the next line. Close the quote. And where do these both of these numbers lie? In the matrix T. Let's type that and run this and see the output. So if the number is 1, then its square root is 1. If the number is 2, then its square root is 1.414, etc. So fprintf is vectorized according to the columns. So it completes one column, then it goes to the next column, similarly till the last column. Let's work on some questions from your textbook. Question 1. The monthly payment M of a loan amount P for Y years and with interest rate R can be calculated by this formula. Calculate the monthly payment and the total payment for a $100,000 loan for 10, 11, 12 till 30 years with an interest rate of 4.85%. Display the results in a 3-column table where the first column is the number of years, the second column is the monthly payment, and the third is the total payment. We define Y as 10 to 30 with increment of 1. The rate R is 4.85%. P is 100,000. Then put in the formula for M with the appropriate dots. The total payment is 12 multiplied with the monthly payment multiplied with the number of years. So we need a dot connecting them. We have an intermediate matrix T equals Y as the first row, M as the second row, and TP as the third row. Next, we'll display the title for the different columns: years, monthly payment, and total within single quotes, and we have used the fprintf command. Below it, we'll display the values. So first is the number of years, so percentage to indicate the number is coming, 2 because the total number of years is coming to 30 as the last value, so 2 spaces, and I for integer, percentage again for indicating that a number is coming, 6 for the field width. How do you decide the field width for the monthly payments? So let's just run this much. And look at the matrix. Look at the second row. The maximum value or the maximum number of field width is for the second row. Let's look at the second row. We have 1, 2, 3, 4, 5, 6. So 6 point. We need to correct it to 2 decimal places. So 2. So that is your precision. And F to indicate the conversion character, which is F for floating point. Similarly for the total payment. So percentage 6.2 F. Now let's run this much. And we have the years, monthly payment, and the total payments. The earlier matrix should now be suppressed. And also it's a good habit to switch echo off before using input-output functions. So let's run this again. We have the final table here, and any vectors that are not required to be displayed should be suppressed with the semicolon. We can also tweak the number of spaces in between all these. We can move these a little bit here, so we can always arrange according to our wish. So we will just run this again. Okay, it looks better. Moving on to question number 2. Display the values corrected to 2 decimal places using fprintf. So that's a note for this question. Write a Matlab program in a script file that calculates the average, standard deviation, and median of a list of grades as well as the number of grades on the list. The program asks the user, so you have to use the input command to enter the grades as elements of a vector. Then the program calculates the required quantities using built-in functions length, median, std, and median. So later it displays the results in the following format. So here we need to use the input command, input, and ask the user to enter the variables, the grades. So enter the grades. Okay, now let's run this part. So here we can enter the grades as a vector, and we have all the grades entered there. Now, because the echo is not switched off, you see these commands. To avoid that, we can switch echo off. Then calculate the length of the grades, vector, mean, standard deviation, median, and let's have a look at that. So enter the grades. Okay, and enter, and we have all these values. Now using fprintf, so fprintf, there are here the numbers coming, so percentage 2i. So the number of grades is 13, so there are 2 spaces for that. So to indicate that, we put 2 and then it's an integer, so you put I, and then close it with a \n so that the next few lines can be printed. And where does this number lie? In L, so you have to indicate that. Next is fprintf. The average grade is percentage, so here we put the percentage sign to say that we are displaying the average grade there. Look at the field width. We have 1, 2, 3, 4, 5, 6, 7, including the decimal point, so 7, and correcting it to 2 decimal places, 2, and then f\n, and it lies in M. Similarly for the standard deviation and median. Now let's run this. Enter the grades. And we have the final results. Okay, the median is percentage 2i. Now this one lies in MED, so that was a correction to be made. Okay, let's move on to the next question. That's question 3. The variation of vapor pressure P in units of millimeter mercury of benzene with temperature in the range from 0 to 42 degrees Celsius can be modeled with this equation, where A and B have these values. They are the material constants, and T is the absolute temperature in Kelvin. Write a program in a script file that calculates the pressure for various temperatures. The program should create a vector of temperatures from T equals 0 to 42 degrees Celsius with increments of 2 degrees and display a 2-column table P and T. So we have T with 0, increment of 2 till 42. We'll convert it to absolute temperature by adding 273. And then define A and B. Put in the formula for P, which will be this one. Now we'll create an intermediate matrix T, or let's call it as M. Then the first row will be all the temperature values in Celsius. Next row will be all the pressure values. Later we'll display the title for both the columns. So we have temperature and pressure. We'll use fprintf to modify the numerical output. So below temperature, we have %2i to indicate that we have two spaces for that field width. So %2 and then I to say that it is an integer. And then the pressure values, we can check the pressure values, the total field width occupied, 1, 2, 3, 4, 5, 6, 7, 8, including the decimal point, and then we correct it to 3 decimal places. And these two values lie in the matrix M. Now let's run this. And here we have the desired matrix. So we can suppress all the intermediate vectors and matrices. Run that again. And that's the answer. Moving on to question number 4. A truss is a structure made of members joined at their ends. For the truss shown in the figure, the forces in the 9 members are determined by solving the following system of 9 equations. Write the equations in matrix form and use Matlab to determine the forces and the members. A positive force means tensile force and a negative force means compressive force. Display the results in a table. So now we are dealing with 9 equations and there are 9 unknowns. So it is possible to completely solve this. But to do this efficiently, we will first create a zeros matrix using the zeros command, and we'll use zeros of 9 since we need a 9 by 9 matrix. Now notice that we have coefficients only for a few of these force values. So most of the values are zeros. The coefficients are zeros in each of these equations. So it is better to use the zeros command initially so that we have a matrix full of zeros. Now redefine the matrix every time. So let's look at the first row. For this one, we will be changing that as A of 1, which indicates first row, first column and the fourth column. We have these values: negative cos of 45 degrees and 1. These are the coefficients of F1 and F4. Similarly for the second row, A of 2, then first and the third columns, we have negative sine D 45 and negative 1. So we continue like that for all the rows until we get the desired coefficient matrix. So let's have a look at that. Then we have the constant matrix B, which is zeros of 4, 1. So there will be 4 rows and 1 column, and then below it all these values. Later we calculate the forces using the left division. A, left division, B. Now we have a vector here called FV, which is the number of forces 1 to 9. We have an intermediate matrix T with FV as the first row and below it the F values as a row as well. Then we have the titles displayed. So FV, F as a string, and below it the different force numbers and the force values. Now notice that we have a plus sign here, so that is a flag, so that when you have the output, as we run here, we get the sign, whether it is a positive force or a negative force. So we can suppress all the intermediate vectors and matrices so that we see only the final result. So let's run this. So we have the different force numbers along with the forces and their signs. Moving on to question number 5. The graph of the function f of x equals this function, which is a fourth degree function, it passes through these points. So we are given 1, 2, 3, 4, 5 pairs, and we have 5 unknowns. Determine the constants A, B, C, D, and E. Write a system of 5 equations with 5 unknowns and use Matlab to solve the equations. Now, since that's a long process, we will define x as all the x coordinates, then use the Wander command to generate the coefficient matrix. So, if you look at the first row, we have -4 raised to 4, then -4 whole cube, -4 square, -4 raised to 1, and then E's coefficient is 1. That will be -4 raised to 0. Okay, and then the next row, so we have -2 raised to 4, -2 raised to 3, etc. So it follows that way. Then we have a constant matrix, which are all the y values as a column. Then we use the left division to evaluate this matrix. So these are the unknown values, A, B, C, D, E. Now we can display this function as using the fprintf. So you start with a single quote, percentage, then the plus sign to indicate whether it's a plus or minus, then the field width and the conversion character, and then x raised to 4 to indicate that part. Similarly for the remaining, and we close that with a single quote after putting the backslash in character. And these numbers that we have just written here using this percentage symbols and all that, where do they lie? They lie in T, but you should make that into a column vector, so T transpose. So if we run this, we get the desired function. That's all for now. Thank you.